Brant, we were talking about this stuff about antiderivatives. Remember antiderivatives?
I mean, yeah,
Huh?
kind of, yeah.
Okay, we use this thing, when we talk about antiderivative, we have a lowercase f, and then the capital F is the antiderivative, which means lowercase f is the derivative of uppercase F. Does that make sense?
Yeah, it makes sense.
We used to call it capital F. I don't think they call it that anymore. Anybody into English here? Or, excuse me, the art of language arts?
I call it capital, that's where uppercase works.
I've never gotten that. I think that's them being innocent. And now we'll be on the abyss and I'll get grief about it. All right. For example, Brant, let f of x equal 3x squared. The derivative is 6x. The expression 3x squared is the antiderivative of 6x. Why? It's almost a ridiculous question.
Because if you take the derivative of 3x squared, you get 6x.
Oh my gosh, that's exactly correct. Oh, I'm using the wrong pen. I've been trying to be better about that. Alrighty. So, long time ago, we had a picture that looked like this, Walker. And here's A, here's B, here's a curve that I'm going to call F. And that's an infinite number of rectangles, correct?
Yeah.
So that's the area underneath that curve. Remember that?
Yeah.
And we had something called a definite integral. So you have this thing that looks like an S, and actually it is an S. It represents sum of the infinite rectangles. And I'm not going to make you do that, okay? We'll probably review that down the road, but it's not necessary today. And it's going to start at A, and it's start at B.
Hat and boots.
Hat? God, yes! I tell that story and people remember that. Here's the hat, here's the boot, and in here is the derivative, right? And that's the big thing to remember, that this is a derivative of capital F of x. And this, to compute that area, do you remember?
It's f of b minus f of a.
Yeah, the antiderivative with b put in it, and the antiderivative with a put into it, and you subtract them, and that gives you the area, correct?
Mm-hmm.
So that's seeming familiar? Wow, that's pretty good remembering that. I'm pretty impressed. Walker, do you remember the power rule?
Yeah.
So what it says right here, it says step 1, multiply by the old exponent, subtract step 2, subtract 1 from the exponent. So this is x, and what would I write here?
It'd be the n in front of x, and that'd be n minus 1 on top.
And you guys thought you didn't remember anything, okay? Alrighty, what about you, Ethan? I'll give you a hint. To do the antiderivative in reverse order, what we do is we add 1 to the exponent. And then we divide by the new exponent. So Ethan, what would this look like? I'll give you a hint. X is right here.
1 over n, or the n plus 1.
N plus 1 here.
Yeah.
Okay, what about here?
1 over n plus 1.
Yeah, I do that. But you could put it all that over n plus 1. I write it as a coefficient. I usually use the reciprocal. I like having the coefficient. Alrighty, Matt, you got 3 in a row to do here. F of x.
1/3 x to the third plus c.
Plus c. And that c is that arbitrary constant, because anytime you take the derivative, it becomes 0. So we know there's one there, we just don't know what it is, right? What about this one? Are you able to do this one in your head, or do you need a helpful hint?
5/4 to the x to the 4th. And then it's gonna be negative would be 3x.
That's a 3, that's a lousy 3. I'm gonna use my fancy eraser. Look at that.
3x over 3x to the negative 2.
Right, because this is a negative 3, if you add 1, you get a negative 2, and then you're gonna take the 6 and divide by a negative 2. And
Minus x plus c.
minus x plus c. So if we wanted to, we could say f of x, since I got all this room anyway, 5/4 x to the 4th minus 3 over x squared minus x plus c. Correct? Okay, what about this one?
There'll be 2/3 x.
2/3, very good.
To the 3/2.
3/2. And you could check, notice there are reciprocals when you multiply, and this has a coefficient of 1 out here. Excellent.
And then a negative.
Well, right now I got x to the negative 1/2, correct?
Yep.
And I'm gonna add 1 to that.
Yeah. Oh, yeah. So it's just gonna be
What's your exponent gonna be?
1/2.
1/2, correct?
6.
And so, yeah, so you're gonna multiply by the reciprocal, and you're gonna get 6. And then what else?
Plus c.
Plus c. Everybody okay with that? All right, Sarah, remember these?
I think so.
Okay, let's see what you do. Because guess what? In 1977, I only screwed this up for about 3 weeks.
Alright, so the first one is negative cosine x plus c.
Okay?
And then the second one is sine x plus c.
Very good. What's on the back side? Anything? Oh, yeah. there it is. And this is what Walker just gave us. Alicia, so we're just going to write it again. And then we're going to do it here. All right. Alicia, let's go to this one. Calculator, oh, use a calculator to check your answer. I'll show you how to do that. You remember how to do that? Hmm?
I think so.
Okay. Okay, let's do a calculator free to begin with. We first find what is the antiderivative?
4x minus 3x squared.
Perfect. And we're going to evaluate it from a negative 2 to 5, correct? And the first thing we're going to put in is what? Right, so I have 4 times 5 minus 3 times, are you okay with 25? And then we got minus here, and we're going to have 4 times a negative 2 minus 3 times, well, negative 2 squared is 4, correct? Right? And so this gives me 20 minus 75, what is that number?
Negative 95.
Negative what?
95.
I got negative 55. 20 is a positive 20, right? 20 minus 75?
Oh, yes, I see.
Okay. And then this is a negative 8 minus 12. Negative 20. So that ends up being what? negative 35. Does anybody not know how to do that on their calculator, or does anybody want to review on how to do that on your calculator?
I'd like a review, please.
Okay, no problem. What brand of
I have a
calculator?
TI 84.
You know, Mr. Johnson was in here watching me, and he was quite impressed by everybody in here. You guys got very high marks. The next thing he said is, you do both Casio and TI. I find that weird. It's like, okay, you can speak Spanish and English at the same time. Which I can't do. What did you want me to do, a TI?
Yeah.
Yeah, unfortunately, all I got is an old TI. So do you graph it? You could do it either way, graph it or not graph it.
I don't know.
Okay, this is the way I would do it on any calculator.
Okay.
Okay. First, I go to my y equals. I get rid of anything that I have here. And you know that you have to make sure that these stat plots are off, right? You know that part? And what I do is I put that equation I put it right into y1. And the reason I do that is I know down the road there's going to be more than one equation, and I'm going to have to use both of them. And rather than screw around with parentheses and all that stuff, which really sometimes messes me up, I just go ahead and put the equation right in there. Does that make sense? Okay, and then I'm going to go to my screen, and you go to math, and you should have an integral sign on yours. Am I right?
Yes.
I think it's line 9.
Yeah.
Okay, so you have an integral symbol, correct? So the first thing I do is I go to vars, and I come over and get that y1. And then you have a d blank, correct, on yours?
Mm-hmm.
Okay, that's where you're gonna put, right here I'm gonna go comma x, but this x goes where that d is.
Yep.
Okay, and then you'll have a place for your hat and your boots.
Yep.
Okay, I don't, so I'm gonna start with a -2. There's my hat, and my boot is what, 5? So this is on the old calculator. This is at the bottom of your integral. This is at the top of your integral. This is where your d is. And you should get that. My guess is yours is faster because you have a nicer processor.
Yep. I got it though. Thank you. I remember that.
Okay? This, they tell me, the AP people, doing it this way is more accurate than using your graph. Because they'll shade underneath your graph. Okay? So if I went to my window, and I'd go from -2 to 5, I hit graph, it'd give me that, and I can go second calc, here's my integral, line 7, then go from -2 to 5, don't shade it in, tell me it's -35. In other words, there's more area below the graph than there is above the graph. And that's an important idea. And this is your net area, not your total area. Alrighty, Alexis, how would you do this? Would you rewrite it to begin with?
Yeah.
So you got x to the 1/2 here, minus x to the -2 dx. And your antiderivative would be?
3/2x. No, backwards. Instead. 2/3 x to 3/2 powered.
Perfect.
Minus -x to the -1.
I have a positive x to the -1.
Same
Okay. Can I write it like this?
Yes.
Right.
Then you have the line 4 and 1.
Yep. Okay, so when you have a half power, that's like taking the square root of this, correct? So what is the square root of 4? 2 cubed.
8.
So I have 2 over 3 times 8 over 1. Are you okay with that? Plus a fourth. Parentheses. And now I got minus sign, I got parentheses again. And I'm gonna have 2/3 plus 1. Are you okay with that?
Yep.
So I said this is 16/3 plus a fourth minus 5/3. Because 1 and 2/3 is 5/3. And the reason I do this is this gives me 11/3 plus 1/4. Common denominator is 12. So I have 44 plus 3 over 12, or 47 over 12. That's back in the day when you guys, see, you guys grew up with these calculators and you didn't have to do fractions ever, did you? Did they ever have you do fractions? Probably. Here's the reason why. Your teachers didn't know how to do fractions because they had calculators. If I were to teach teachers, I would make them use a slide rule. Tell your mom that. My wife would hit me with a slide rule if I told her that. All right, Lucy, I can bring that 4 out front, right? You're okay with that?
Yep.
So what's the antiderivative of sine?
A negative cosine.
Right, so I got negative cosine x from 0 to pi over 2. And I'm going to multiply that answer by 4. Are you okay with that? So I got a 4 here. I got negative cosine of pi over 2 minus a negative cosine of 0. Are you okay with that?
Yeah.
So, what is the cosine of pi over 2?
0.
Big fat 0. Plus, right, because I got minus a negative? What's the cosine of 0?
1.
1. Well, now it got nice, didn't it? 4. All right. I actually, when I did these notes, I did these 2 ways. Both of them are correct. One doesn't have more of a better answer than the other. So we're integrating, so we're looking at the area from here to here. So this area, I wrote a little note. Area is how much f of x increased from the point (1, negative 2). So if you notice, they give you this point 1, negative 2. So this area is the amount of increase, because if this is the derivative, it decreased for a little bit and then increased beyond that, correct? So the y value of the antiderivative dropped that amount and then increased that amount. So there are 2 ways to do this, Ethan. Either way is correct. What I did to begin with is I solved a particular solution. So I figured out the antiderivative. I said, okay, I know F is equal to what? What's the antiderivative of that?
1/3 x to the third minus 2x.
Plus C,
Plus,
right?
yeah,
And then this point gives me that C, doesn't it?
yeah,
We've just done a whole bunch of problems like this, correct? So you would put -2 here, you would put 1 into here, get 1/3 minus 2 plus C, correct?
yeah,
And if I add 2, this -2 becomes 0.
yeah,
So a -1/3 becomes C. Are you okay with that?
yeah,
So that means f of x equals 1/3 x cubed minus 2x minus 1/3.
yeah,
Am I going too fast?
no,
And then I could plug 3 into that and get 1/3 times 27 minus 2 times 3 minus 1/3.
yeah,
This is 9 minus 6.
3,
3 minus 1/3, 2 2/3.
yeah,
So this is equal to 2 2/3, or what we call in the business 8/3, correct?
yeah,
This is just what we got done learning, correct?
no,
Okay, right? Now, here's in the form of an integral. So, I started at a -2. This is my amount of increase from 1 to 3. Everybody with me so far? So I got -2 plus, and then I got these brackets, and I got 1/3 x cubed minus 2x evaluated from 1 to 3. This again is my amount of increase or my amount of decrease, depending where my graph is, right everybody? So this gives me a -2 plus, and if I put 3 in there, I get 1/3 times 27 minus, I'm just gonna say 6 right away, minus, and then I'm gonna have 1/3 minus 2. Ethan, I believed you said this was 9 minus 6, which is 3, correct?
yeah,
1/3 minus 2 . Oh, this should be a plus sign. God, I almost screwed up. This is going to be a negative, what, 1 2/3?
yeah,
So I get a -2 plus 3 plus 1 2/3. Would you agree with that, Ethan?
yeah,
What's a -2 plus 1? And what's a -2 plus 3?
1,
Thank you. What's 1 plus 1 2/3?
2 2/3.
2 2/3. If you were asked this question on the AP exam, I have seen both of these answers get full credit. One is from using finding the particular antiderivative, and here's using integration. Yes, ma'am.
Why do we put in the -2 for the second option?
Because we start at 1 at a -2. That's our initial value.
So the given point, that's just always what we would put outside of the integral?
Correct.
Okay.
So this is the amount of increase or decrease. So you'll see it in a real world problem like this. I got a tank. There are 3 gallons of water already in it.
Oh, okay.
And water's coming in at time equals 0 for 5 hours. Well, you gotta include those 3 gallons, did I say 3 gallons?
Yeah.
Those 3 gallons, and then that's the amount of increase, and then they'll also say, guess what, there's a leak going on, and I don't care what the problem is, it doesn't have to be a tank, there's something coming in, there's something going out, and there's always an initial value. And it's really this problem right here.
Okay.
Does that make sense? Okay, and the reason I'm spending more time, I don't know if I said this to you guys on Friday, I felt I didn't do a very good job last year, and some people were a little confused with integration and anti-derivatives. So I'm taking some time to fill in those gaps, okay? But it seems to me you're doing pretty good. All right. All right, did that side, and then I gave you one more, right? And this is the one that I think, Walker, you said, yeah, I've been waiting for, right?
Yeah, that's good.
So I'm gonna talk about substitution, okay? And I don't care how you do substitution, okay? There's 2 ways. I do U substitution and I do pattern recognition, okay? And so I'm gonna talk about pattern recognition first. And this is a conversation I had with you, Sarah, I think on Friday. I think, or maybe it was Thursday, it was sometime last week, okay? And there's an advantage to pattern recognition is that it's faster, okay? But the problem is sometimes being faster doesn't mean you're gonna be accurate. You understand what I mean?
Yeah.
So this is how I view this. I know that has to be a derivative, correct? And we don't have any problems with derivatives until we come along to the chain rule, correct? And if I have parentheses in here, that indicates to me that the chain rule had to be applied. So I look in here and say, hey, the derivative of what's inside better be part of this entire derivative, because the chain rule requires it. And sure enough, the derivative of x squared is 2x, and it's here. So what I can say is, hey, this is simply going to be x squared plus 1. I'm going to add 1 to this power, get 13, and then multiply by its reciprocal and add c. It's really, really fast, correct? Now I check. 13 times 1/13, does that give me a coefficient of 1? Does this drop down by 1 and become 12? Do I go in here and take the derivative because the chain rule requires it and see a 2x here? Yes, I do. I'm done. But not everybody sees that. So U substitution says, hey, if you see something in the quantity, let U be that value. And then take its derivative. And you're going to substitute everything inside this, everything, including the dx, you're going to substitute everything in there, and it's all going to be in terms of U, every single thing. And when I take that derivative, I get 2x. And when I multiply both sides by dx, I see, oh yeah, I have a 2dx, that's going to be replaced with du. So this becomes u to the 12th power du. Where did the u come from? It came from x squared plus 1. Where did the du come from? It came from 2x dx. Well, now it's really simple. I got rid of this complexity. And I can apply my rules and say, hey, the Ethan Martin rule of integration says that. And then I can come back in and substitute my u. And Walker, to be honest with you, I try this every time, personally, okay? You don't have to be like me. But sometimes I get stuck doing this, then I immediately go here.
Okay.
Because this is just algebra over here. So again, I see this. That means there needs to be an 8x cubed, correct? There isn't, is there? Okay. So what I do is I do this. I bring this 3 out here. I actually rewrite it so it looks like this. Here's my dx. I bring my x cubed over here. Are you okay with that?
Yeah,
Does it bother me that I'm talking to you and talking to everybody at the same time?
no, that's fine.
So I need an 8, don't I?
Yeah.
Because that requires an 8. So I put an 8 here, but then I have to divide by 8 because 8 divided by 8 is 1. So then I can say my answer is 3/8. What's the antiderivative of sine? It's negative cosine, I believe, correct? Okay. All right,
That's it?
I be done. I be done. That is so Wabash County, I be done. Chuck, are you done welding? I be done, Dad. Okay, so let me show you substitution. Again, this is what's in parentheses. So I let u equal 2x to the 4th plus 1. I get du dx is equal to 8x cubed. But I don't have an 8 there, so I write it like this. 1/8 du is equal to x cubed dx. Okay, so the 3 is going to come here. Because I could always, when I multiply by a constant, I can always bring it up. And I'm going to have the sine of u. And this dx is going to be replaced with 1/8 du. So this was dx right here. Well, now that I have another constant I'm multiplying by, right?
Yeah.
So now I have 3/8 sine of u du. And when I do the antiderivative of that, I get a negative 3/8 cosine of u plus c, and lo and behold, then I change it into that. Yes, ma'am?
Why do we divide by 8 so it turns into 1/8 du?
Because I don't have an 8 here.
This is the first time
So what I kind of did, I should have said I bring that 3 out here. I have sine of 2x to the 4th plus 1 x cubed dx. So I can replace this with du. I can replace this with the sine of u. And then I keep the 3 there.
So how do we know when to do that?
I look to see if when I came up with this 8x cubed, I look up here to see if this is 8x cubed.
Oh, okay.
It's not. Okay, well, how do you make, and you could say, hey, how do I make a 3 into an 8? You understand what I'm saying? But to me, it's easier to just say, well, okay, I can bring that 3, ignore it for, but I can make this x cubed dx. It will replace.
Oh, yeah, I get it.
Okay, but I can't replace it with a straight du, it's gotta be 1/8 du. Because that's the equivalency. Okay?
Oh, yeah.
So, this is what I'm gonna do here, I'm gonna rewrite this. That's a constant. I don't like that pi in the denominator, it messes with my brain. Okay? And I don't like the cube root, so I'm gonna write it like this. And I look inside of that. its derivative is 2x plus 2, correct? You know that. And over here I have x plus 1 dx. I am so close, Lucy. All I would have to do to that to make it 2x plus 2 is do what?
To make it 2x plus 2?
Yeah, how do I do
Multiply
that?
by 2?
Multiply by 2. Would everybody agree? So if I multiply that by 2, but I can't I'd have to compensate for it by multiplying by a half. So this is the derivative of what's inside, correct? Okay, so now I know I can apply my power rule. And I'm gonna add 1 to here and get 4/3. I'm gonna multiply by the reciprocal. I think that's 3/4. But I still have 1 over 2 pi here, plus c. And then I'd write this 3 pi over 3 pi. Oh, good thing I got an eraser. I'm really liking this. I hate to tell you, it's better than whiteout. Whiteout is expensive. 8 pi x squared plus 2x. So I did that totally without substitution. Branch, you got a question on that, or is that okay?
Oh, it's making sense.
Okay. Walker, you got it on that?
It's doing good. I'm doing good, yeah.
Okay.
Makes sense.
Do you see the advantage of that?
Yeah.
Even with this, there's a lot of space that takes up. Are you okay with it? You want me to do substitution? I will.
I like substitution
Okay.
more.
You want me to do substitution here?
Sure.
Okay, I'll do it up above.
Okay.
What do you think u should be?
The x squared plus 2x.
Yeah. And then you're gonna tell me du dx is equal to 2x plus 2, right?
Mhm.
But this is x plus 1. So that's x plus 1 dx. So I'm gonna skip a step, and I'm gonna write 1/2 du is equal to x plus 1 dx. Are you okay with that?
Yes.
Okay. So now I've got everything I can substitute. So because that's a constant, I'm gonna bring the 1/2 out here.
Yep.
I'm gonna bring the 1 out of pi here. This is going to be u to the 1/3 here, and this is going to be du. Because there's my 1/2 du, which is my dx,
Yeah.
correct? And then you can go from there.
Mhm. Okay.
And there is nothing wrong with that, okay, absolutely at all, okay? It's all about your success and comfort level, that's what that's about. I remember I'd have college profs and they just do that, they said, well, it's obvious. Well, okay, it's obvious to Mike Schweitstall and Jackie Rasmussen, but it's not obvious to Chuck Kruger. So I guess I gave him a phone call. Okay. Because you didn't interrupt the professor, because they work on that. Everybody else is asking questions. All right, what about this one? Let's do u substitution. What would you let u be?
Cosine of 2x.
Yeah, exactly. So du dx is equal to what, Walker?
Is it 2? Is it -2 sine of 2x?
Yep, perfect. Perfect, perfect, perfect. Okay? And notice, this is not a -2, is it? So I have this and this, which is going to be du. So I'm going to write this as a -1/2 du is equal to sine of 2x dx. So do you see where the negative 7/2 integral comes
Yep.
from? And what I'm left with, which really pleases me, is e to the u du. Because this became du. And now, okay, I cannot make an easier integral than e to the u du. Because there really isn't anything to do, right? So I'm going to get negative 7/2 e to the u, but u was the cosine of 2x. Let's see. So look how miserable that looks like and how all of a sudden it became extremely simple. If I would have showed you that you'd be able to do that last year on the first day, all of you would have dropped out the next day. Seriously, that's like craziness. When I got my calc book, I looked ahead and said, oh man, maybe welding was a lot easier. Okay, what do you think u is here?
Cosine squared 2x.
Yeah, cosine squared 2x. So I'm going to write it this way. And the reason I do this is because I always screwed up when I was in calc. Anybody want to take a shot at that? Is it positive or negative?
I don't know.
Well, do you see where I get the 2 to begin with?
Yeah.
You see where I get the cosine of 2x? And I'll have a little box here, it'll be in the first power, right? Then I come in here, what do I get? Times negative sine of 2x, correct? And then I come in here and see what?
2x, which the derivative is 2.
Is 2, right? Okay, so this gives me negative 4 sine of 2x cosine of 2x, correct? So I got 7. That's not a 7. And I go, poop. I got the cosine of 2x. And this is going to be gone. So I'm going to just put this in here. Oops, eraser. I'm almost at the point where I'm making mistakes just so I can erase. Everybody okay? It gets better. Trust me. Trust me. So, everybody okay there? Everybody okay here? This is the poopy part. Would everybody agree?
Yeah, that's weird.
Right, because it's there. You can see it right here, can't you? If I could only know what the cosine of 2x was, right? Everything's got to be in terms of u, correct? This is in terms of x. X is not u. X is Twitter. That was a joke. Or formerly, is it Twitter? Yeah, I don't know. If I could only get that in terms of u. Anybody got any ideas at all? Are you saying, from here I can say u to the 1/2 power is equal to the cosine of 2x? Yeah. So now I can say I've got this. A -7 force integral u to the 1/3 over u to the 1/2 du. Is everybody okay if this was under du and I just slid it over here? Everybody okay with that? What do I do here? What do you do when the bases are the same? What do you do with the exponents when you divide?
Subtract them.
You subtract them. So now the problem is, what's 1/3 minus 1/2?
-1/6.
The -1/6. This was, how did this, does that look like a 4 to you? Erase. So I can say I got -7 force integral u to the -1/6 du. So that gives me -7 force times u, I'm gonna add 1 to that. That gives me 5/6.
Mm-hmm.
And here I'm gonna have 6/5. And that's gonna give me a negative, I don't know, -42 over 20, a -21 over 10. What was u? U was the cosine of 2x squared raised now to the 5/6 power plus c. So I suppose I could multiply that and get 10/6, which is 5/3. Or I could just leave it like that and say I'm tired and be done with it. Whatever happened to you, Alexis? Sometimes you're tired and you just say I'm gonna stop here.